All right. Of course, here's our warm up. Any final questions? Anything you want to look at from these before? That's fine. All right. So we have in what we were doing right here. Let me just remind us of some vocabulary that we were doing here. We called these where we have our plus c at the end with this notation. We were taking an indefinite integral and we were getting what we called a general solution. This right here, all four of these are general solutions to indefinite integrals. Today we're going to look at finding particular solutions for indefinite integrals. The difference is going to be a particular solution, we're going to actually find a specific value of c. Because c is obviously, as we've talked about, it's representing any constant. But a particular solution is going to be a very specific answer. It's going to be a very specific function that the problem is looking for. So let's look at a problem. Here you go. It says find the general solution of this derivative, and then find the particular solution that satisfies this initial condition right here. Okay? A lot of stuff has been put on the board there, a lot of notation, a lot of vocabulary. So finding the general solution of a derivative, well, we know that if we have the derivative of capital F, if we integrate that, if we integrate 1 over x squared with respect to x, that's going to give us regular capital F, because undoing a derivative, performing the antiderivative, that is just our indefinite integral. Nothing new about that. And they say find the general solution first, so guess what? We're going to start with doing the exact same stuff that we've been doing. I can rewrite this first to make this x to the negative 2. Again, I still haven't integrated yet, so I still have my dx, I still have my integral symbol. And I'm going to do my reverse power rule. I'm going to increase the exponent by 1. I'm going to divide by that new exponent. I'm going to put my plus c. And here is a problem where it is going to be very helpful for us to simplify. So capital F of x, the general solution is negative 1 over x plus c. I am going to simplify that. Not that we have to answer the first part of the question, but it is going to be helpful for us as we find the particular solution. So x to the negative 1 went to the bottom. There's a placeholder of 1 at the top, and 1 divided by negative 1 is still negative 1. All right, any questions on how we found that general solution? You ever watched How I Met Your Mother? General solution? Joke. General. Okay, general solution. There we go. All right. So the particular solution. We want to know what C actually would have to be in order for this to be true. Notice that is good old capital F, not derivative. That is the capital F of x, and we have the capital F of x. We undid the derivative, we have that function, and so all we have to do to find C, to find this particular solution, is actually very simple. We are going to plug in that 1 for x, plug in that 0 for the output, and figure out what C would have to be. So I'm putting in a 1 for x, that's negative 1 over 1 plus C, and we know when we plug in a 1 for x, this is supposed to equal 0. This is our initial condition, which is just, initial condition is a fancy way of saying a point on the curve. This is some point on this function. And we are going to use that one point to figure out what C has to be to make it true. So this is negative 1 plus C equals 0. And in this case, in this particular solution, C could have been anything that is a constant value, but in this particular case, to make this true, C has to be 1. So our particular solution, again, there was the general solution. Our particular solution is capital F of x equals negative 1 over x plus 1. That is our particular solution. And that's it. Find a particular solution. Thoughts about that? I do have a graphic that kind of illustrates what's going on as well. If I just delete some of this because it's going to appear right there. Here's just showing us what this was like. Here is our general solution, negative 1 over x plus c, with c being lots of different values. And of course, c also could have been decimal values in between these. But negative 1 over x, again, for x being greater than 0, that's just the way on the setup. We're only looking over here in these positive x values. Our function, depending on our c value, gives it all these different possible, it all looks the same, but it's just in a different location, essentially. And there is our point that we had to satisfy 1, 0, and it's only this one where our c value is 1 that actually satisfied that initial condition. And depending on the c value, it would just be raised or lowered based on that. Which kind of illustrates what's going on a little bit. All right, I'm gonna let you try some. Any thoughts, questions? Okay, take a look at these three. All right. Yeah, it's basically the same thing except for less words. Okay, so you are looking for the particular solution. So this first one, you're looking for good old g of x. They gave you g prime. You're looking for g of x when it satisfies that initial condition right there. On this next one, we're looking for f of s. They gave us the derivative of f of s. And the last one, which you absolutely can do, but you're going to have to think a little bit more. The last one, we're looking for f of x, and they gave us the second derivative. Ooh. So think through these three, try them out. I'm here to talk about them. I'm walking around. Let's see if we can find these particular solutions.
I don't think we can guarantee that one. I don't think we can guarantee that. What? What did you say? Oh. I think eventually I will.
See, I thought you were gonna start. See, you started.
get 200 for C on 40? Felt too good to be true, like I made a mistake somewhere. Cool. All right, I want to walk through that last one together, but first, any questions about how we set up, eventually found what C is on those first two? All right, so 44, they give us the second derivative, and then they give us an initial condition of the first derivative and an initial condition of the original function. We're obviously trying to find that original function. What is f of x is our ultimate goal, and we're starting with the second derivative this time. So if I start by undoing the first derivative, or undoing one of the derivatives, backing it up one by integrating sine of x, I get from the second derivative, I'm backing it up to the first derivative, and when I integrate sine of x, I get a negative cosine of x plus c. Because think, the derivative of cosine is a negative sign, the derivative of negative cosine would give us that positive sign. I'm constantly checking myself by doing a quick derivative to make sure it's going to go back. Because again, I've taught this class, is like the fourth or fifth time I've taught this. I'm still way more confident with derivatives than integrals. So I want to rely on my derivative abilities to help me out and double check myself. At this point, I know I've got to integrate again to get f of x, but when I integrate a constant with respect to x, it's going to produce a term. So I need to know what that c value is before I do another integration. And they gave me the ability right here to figure out what that c value would be in my first derivative. When I plug in a when I plug in a 0 for x, I get out a 1. So I have negative cosine of 0 plus c. Cosine of 0 is 1. So I have 1 equals negative 1 plus c. So the c value in this moment is 2. Based on that piece of information, my first derivative is a negative cosine of x plus 2. And I basically need to do all that one more time. I need to integrate again, getting f of x. When I integrate a negative cosine, it's going to give me a negative sine of x plus 2x plus c. So again, think we are integrating with respect to x. And if you have integrating a constant, we get that constant times the variable. Double check yourself with a derivative. The derivative of 2x is 2. So double checking ourselves along the way. Finally, we find that final constant value by plugging in a 0 for x and a 6 as our output. Sine of 0 is 0, 2 times 0 is 0, so 6 is that last c value. And so our function, capital F of x, not capital F, it's just still lowercase f, but f of x is negative sine of x plus 2x plus 2x plus 6. Started running out of room there. Pretty big problem right there. Thoughts, questions on that? Cool. All right. For good measure, here is one more of those type of problems. Let's see if we can find that original function. See if we can handle this. Hopefully you can. I think you can. Feel great confidence in you. So there's my answer already. This one was pretty nice because the antiderivatives were pretty nice, but again, you get a chance to kind of practice that process. Obviously, hopefully, doing the reverse power rule for these was nice. It was like a nice breath of fresh air, where that was very simple. And that's what I got for my final function. My particular solution. Any questions about how we got there? All right, cool. For the rest of class, I am going to I'm going to pass out your homework that you turned in yesterday. It is graded, checked over. I was pretty lenient as far as grading it goes. I